Welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Summit Academy. In this video, we're working on that Unit 7, lesson number 11 now. Still talking about that scientific notation, and we're working on those number lines. And so what we're going to be able to do today is we're going to be able to visualize small numbers on a number line using powers of 10. So on the first part, it says Kieran drew this number line. It says Andre said that doesn't look right to me, and explain why Kieran is correct, or explain how he can fix the number line. So we're going to say that what we can do is, if you're looking at these values, again, as they're going to the right, they are increasing. But if you look at that last value, you'd say, hey, that value is actually smaller than any of these that are on the number line. So we're going to say what we have to do is change 10 to the negative 5 power to 10 to the negative 3. We're going to say, since the numbers are increasing. Try the G again. All right. Then on the next part, it says different number line for here, and it says to label the tick marks. So let's do that first. So since I have that for right value is 10 to the negative 5, I can fill in 10 to the negative 6 for each of those points. So now that we have those labeled in there, you can notice how they're increasing. It's 1, 2, 3, 4, so on and so forth, but each of them are going to be to the negative 6 power because our end is going to be negative 5. And so now what we can do is we can plot those points. For number 2, it says plot these falling numbers on the number line. So we have point A is going to be 6 times 10 to the negative 6, which is right here. So I can plot the point right on that tick mark and label it A. Then we can say for the next one, it's going to be B, which is 6 times 10 to the negative 6, or sorry, to the negative 7 for this one, which is very similar to if we did, this is equal to 0.6 times 10 to the negative 6 power. So what we can do is say, hey, that's going to be on the lower end because it's still under 1. So that's going to be B. Then you can say for C, if we want to rewrite that, again, that's going to be 2.9 times 10 to the negative 6. And so that's going to be just below 3. We're going to label that as C. And for D, you can rewrite that as well. So I'm going to rewrite this be equal to 7 times 10 to the negative 6 power, which is a tick mark on here, and label that as D. Then for number 3, it says, which is larger, 29 times 10 to the negative 7 or 6 times 10 to the negative 7? So we need to say for this one, and that's going to be just like our point C here. So this is 2.9 times 10 to the negative 6. That's going to be actually less than our first one. We're going to say this is going to be less than that value for A, which was 6 times 10 to the negative 6. And if we look again on our number line, we are saying that A is further to the right, and we're going to say that, so this one is larger. We're going to say it's going to be larger by about 2 times. Because if we check the length from 0 to C versus 0 to A, it's going to be about 2 times as long. And for number 4, we're saying which one is larger, 7 times 10 to the negative 8 or 3 times 10 to the negative 9. And we can estimate how we know. So let's say that this is going to be, if we wanted to change it so that way they have the same exponent, again, this would be 0.3 times 10 to the negative 8, which is going to be less than. So we're going to say that this is less than 7 times 10 to the negative 8. And we can say, again, this is this is going to be the larger one. We're going to say larger by about 20 times. So quite a large difference because we're talking about, how much larger is it compared from 7 to 0.3. All right. Then moving to the next part, talking about atomic scale, it says the radius of an electron is 0.003 centimeters, very, very small number, and it says to write this number as a multiple of power 10. And so what you do for this is you have to count zeros. And so what we do is we move that decimal place just to the right of the 3. So I'm going to say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to say I move 13 times. And so what I do is I'm going to write it like this. I'm going to say it's going to be 3 times 10 to the negative 13. And we're going to say centimeters. And so now we can label these tick marks. And if we are trying to talk about, we have negative 13, we're going to say that this is going to be this value right here on the far right is going to be 10 to the negative 12 power, since these values are going to be to the negative 13. So fill in these tick marks here in a second. All right, so each of these numbers in here, we're going to say those are going to be those tick marks because each of them are power of negative 13. So we have 10 to the power negative 13 for each of these numbers, but we're just increasing by 1. So we have 1, 2, 3, so on and so forth, all the way up to 9. And then as soon as we get to 10, we can just change that exponent since we're increasing that number. All right, so now that we have that, it says label each tick mark as power 10, and then we have to do this part C, which is to plot the radius of the electron on it. So what we're going to do is we're going to take this number, which is going to be that 3 times 10 to the negative 13, and we're going to label that as that C because that's what we have for that part there. The same kind of setup for the mass of a proton. And so what we can do is, let's move these decimal places over so I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Make sure you can stop. Again, once you get a number that is greater than 1 and less than 10, you can stop right there. So I'm going to say it's going to be 1.7. So this number should be always less than 10. I have 1.7 times 10 to negative 24 power. Again, notice how our answer isn't negative, but it's a very small number. But that's okay. So now we have to label our tick marks, and what we can say is for this one, let's label our far right tick mark. Since this is negative 24, we're going to say they're going to be 10 to the negative 23. And so each of these are going to be 10 to the negative 24 power. All right, now that you have your tick marks labeled, again, each of them times 10 to the power negative 24, and we're saying, okay, we need to put this value, that mass of the proton, we need to plot that on the number line here. So we're going to say it's going to be just below that 2 times 10 to the negative 24, so we're going to put it right about here and label it as C again because that's our part C. So just make sure that you're labeling those tick marks, and since those exponents are negative, as your values increase, it's going to be a negative 23 as the final exponent. All right, then on the back, different number line again, and it says point A on the zoomed in number line describes the wavelength of a certain X-ray in meters. And it says to write the wavelength of the X-ray as a multiple power of 10. And so, they have powers of 10 to negative 12 exponent, but then in between 6 and 7 is where we have it. So we're going to say that this value right here is going to be 6.1 times 10 to the negative 12 power. So we can label and say, okay, for part A, our power, we can rewrite it like we have on the number line. That point A is going to be 6.1 times 10 to the negative 12. And then we can rewrite it as a decimal. So what you do is you have your exponent, and you can count your number of zeros. So we're going to say we have 12 zeros. So I'm going to write it like that, like this. I have 0 point, so I'm going to say 12 zeros. So I have 0 point, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I have 6, 1. So again, if I ever need to switch back and forth between these two, I should be able to have it carefully. So let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Moving on to those practice problems. Talking about those exponent rules again. So make sure you can write it several different ways, but it says select all the expressions that are equal to 4 times 10 to the negative 3. So again, remember, this is a positive number. Positive number. So in that first one, it says 4 times 1 over 10 times 1 over 10 times 1 over 10. So we're going to say that this one is good because we have circle A. Try that again. There we go. So it's almost like we're flipping, again, 10 to negative 1 is the same as 1 over 10. However, for B, we're going to say that one's no good because, again, that's negative numbers in front, which is not what we're looking for. However, for C, if we wanted to check to see if it worked out, we could say, okay, we have 1, 2, 3, so that would be the same as 10 to the negative 3 power, which is what we're looking for. However, for D, that one can't be right because we just have that same form. Do red for that one. So D is not good. What about for E? Same kind of idea. We have 1, 2, 3. So that's the same as 4 times 10 to the negative 3 power, which is what we're looking for. So it's only going to be those three because that fourth one, or that last one is not good either. Then for the next part, or the last practice problem, it has to write each expression as a multiple of a power of 10. So all you have to do is move that decimal place over. So I can say I move it 1, 2 times to the right. So that's going to be the same as 4 times 10 to the negative 2 power. Since I moved, let's say I moved decimal 2 times. Then I could say for same idea for my part B. I'm going to move it 2 times to the right. And so I'm going to say I have 7.2 times 10 to the negative 2 power. So this one, I want you to pause for your term. So this one, try on your own. Make sure you write it with an exponent of 10. Then for part D, what I can do is let's write down the number. So let's say if it's 0.003, I can rewrite that to be the same as I move my decimal 3 places to the right, and so I'm going to say it's going to be 3 times 10 to the negative 3. And then for these part E, F, and G, I can rewrite them like this. So I'm going to say it's 0.23. I have 0.729. Then I have 0.000041. And so what I want you to do is to write whatever number it is times 10 to the negative exponent. So pause for your turn on these as well. And make sure and check with me. All right, and then lastly for the exit ticket, it just says to write that decimal value as a multiple power of 10, and then to write this decimal times 10 to the negative 7 as a decimal. So make sure you're just moving that decimal place out, so that way you have a number, so you're going to say for this one it's going to be 3.4 times 10, and then you're going to have an exponent, so you have to fill in this exponent. And then for this one, you should circle your exponent and count your number of zeros that you have. So make sure you can try that one out. Be sure to ask questions as they arise, and as always, super slam that subscribe button.